One more set of multiple choice questions. All right, let's begin. Number 16. So we have a velocity versus time graph. Now we want to come up with a position graph. So what's going to happen is we're going to go forward, speeding up, and then we've got a little area where we're going at a steady pace, so I'll make that linear. But then we continue to go forward and we slow down, so our curve levels off. So we get this nice serpentine S curve. Choice D. All right, number 17. Oh boy! We have a graph of force versus time, and we want to know the acceleration of the block. So this is a common thing. Like, I'll use the word force, but I'll ask you for acceleration. So just remember, acceleration is force divided by mass. Gosh. So the force at 2 seconds is 4 newtons. That's the force. And then to get the acceleration, let's divide by mass, which is 3 kilograms. So we get 4/3 meters per second squared. Now, okay. Now, here, I gave you a really horrible hint. This is the hint I gave you. Let's make this hint look even worse. We know that acceleration is force over mass, so that's F over m of t dt. What a hideous looking problem. But the trick is, we're just going to get the area. So the velocity is going to be 1/2 base times height of this area thing, and we'll divide that by the mass. So that's going to be 1/2 times my base, which is 2, times my height, which here is 4. I'm taking the area of this triangle, and I'm dividing it by the mass. So the height's 4, and then I divide by the mass, which is 3, so I'm getting 4/3 meters per second. That's number 18. Now, here. For number 20, I'm just going to skip to number 20. My ideal would be if you actually could just write down E right away, having memorized it, but if you can't, let's just remember V is negative gt plus V naught. We're reaching 0, and our launching speed in the y direction was V naught sine of theta. So I'm getting half the time is V naught sine theta divided by g, and then I'm doubling it to get the whole time, and that's how I'm getting E. Now here, we want the tension in the rope. Oh my goodness. So, I think we can just give up on answer A being the answer. That's the one they want you to circle, and that's the one a lot of people circle when they panic. They're just kind of like, oh hey guys, Facebook sent me a notification. You needed to know that while I was recording this video. Okay, cool. So, number 19, let me finish that. Oh my gosh, it's clicking into my ear. It's driving me crazy. Shut up, Facebook. Get out of here. Oh, gosh. This totally ruins physics. No wonder. No wonder you're so resentful about this test. What kind of videos is this guy recording anyway? All right, so we got little m and big M. Let's set up our equations. And we'll make this the positive direction. So I have T. I can't even draw a free body diagram. Okay, T and then big mg here. And on the other side, we have T and little mg here. Let's set up our equations. So I'm going to have mg minus t equals big M times A. And then we have mg minus t equals little m times A. Now, what I'm going to do is I'm going to divide the top equation by big M, the bottom equation by little m, and set them equal. So I'll get mg minus t over big M equals, and actually I have this backwards. This should be, this is okay, but the other equation should be t minus little mg. So I'm going to end up getting t minus little mg over little m. And then what I'm eventually going to do is multiply both sides by little m and big M. So I'm going to get little m mg minus t equals times little mt equals big MT minus big M little mg. And when I actually solve, I'm going to end up getting choice C as my answer. That's a lot of work, but I'm being kind of mean and making you finish that algebra on your own. So that finishes up the multiple choice, and then I will do the free response in the next set of videos.